welcome back. We are now going to dive into some data actually related to the built environment. The data set we'll look at today is the Building Data Genome Project 2. This is a large energy related data set from thousands of buildings across North America and Europe, which are its whole building energy meters, electricity, hot water, chilled water, steam, and different, basically at a high frequency, at hourly frequencies. As we learned previously on Kaggle, you have this opportunity to upload data sets. So I've uploaded this data set. This is actually a data set that we've been accumulating now, my team and lots of collaborators now for a couple of years. It was used in the Great Energy Predictor 3 competition, which you'll find out about in future sections. If we dive right into this data set, you'll notice that there is a lot of documentation down here. There's actually a whole journal article, which is open access. You don't need to pay anything. You can read through it. And we put some of the details of that documentation here to just give you a sense of where this data comes from and what type of data it is. It's essentially from quite a few buildings, broken down according to different primary uses, from education to office to entertainment, all the way down here to residential and lodging. You've got quite a bit of electricity data. You can see over 50% of the data set is electricity, but we also have chilled water for cooling, steam and hot water, even gas, water, potable water, and irrigation. You can learn a little bit more about the different data, kind of a breakdown. This is kind of the exploratory analysis, but we'll also do some of that later. And if you come down here to the Data Explorer itself, you'll see that there are several different files here that you could access. So each of the meter types, electricity, chilled water, etc., has a file .csv, which we'll show you how to load here in a second. We also have other CSVs, which are clean data. We've removed some of the outliers, and the methodology for that is contained in the publication. And here you can see an example of what the data looks like. This is the chilled water file. You can see that there's a timestamp column, which will probably load as the index. And then you have over 500 columns of basically the different buildings that are in this data set. You'll notice that the label for each building includes a animal name, in this case panther. These initial animal names are indicators of which site the data is from. If you want to find out exactly where that is, then you can look at the publication. There's kind of a key for most of the locations. It has office, which is the building use type, and then it has some sort of human readable name. You can't see it here. It's kind of, we'll show you when we start analyzing the data here in a second, which is a unique name. We give them human names instead of just like some number. So as you're doing analysis, you can actually call them by their name essentially. So this data set is available for people to download, to create notebooks or code, to do discussions. You can kind of do lots of things, and tasks, which we'll also talk about in future lessons. Let's dive into one of the notebooks that's contained in the notebooks field. There'll be a link for this for you to easily find it and clone it into your Kaggle account. This notebook, we're going to go through and show a lot of the techniques that we've looked at previously with pandas and data cleaning. We're going to apply to this data set and even introduce a few additional ones. So this analysis was created by myself. There are some tutorials here related to time series analysis functions. What we're going to be looking at is really how to analyze time series data, which is super important in the built environment, especially in construction and operations, where you're actually implementing devices and collecting lots of data from those devices. So the Building Data Genome 2 project, you can find out more about on the GitHub repository as well. GitHub is a website where you can learn, or you can upload data and code and different things. It's kind of similar in some ways to Kaggle, so check that out as well at this link if you'd like. So first thing we're going to do is load the pandas library. Of course, that's going to be the main focus, is the pandas time series analysis functions. And what we're going to do is also load the electrical meter data file that is not the cleaned version. So we're going to get like all the messy data and the outliers and all the things that we want to try to play around with and look at. We'll load that file. Of course, as per the last set of videos, you can see that over here on the right, you can see that the data set has already been loaded. You can see the various files, the file paths themselves you can create or click on. This is the file path for the electricity file, which we're going to look at. So first thing I always like to do is do a .head, take a look at what we've got here. We've got that timestamp column. We have the various columns I mentioned before. It's the name of an animal, which indicates which site it is. There's 16 sites. Parking, in this case, for this first column, is the building data use type. And Lorraine is just some arbitrary name, human name that we gave this building, which is unique amongst all the other names. The name of the building has nothing to do with the building itself. It's just a way that we as humans can refer to buildings almost in a similar way as humans. So we also can look at, of course, use dot columns to see the number of columns here in the data set. There's over 1,500 total building electricity meters in this data set, which is quite a few. We can, of course, pull out a meter example. In this case, we're going to look at, from the Panther site, the education building called Genome. So let's go ahead and run that. Let's take a look at that meter data itself. Here you can see that the first few rows of Jerome's data set are zeroed out. You can see that the index of the first one, so dot index, allows us to actually look at and the zero indicates the zero index. We're looking at what is the number here. So this allows us to learn more about how to isolate or to select different parts of the data set. As we learned about previously with date time objects and how useful they are, of course, with time series data for meter data, it's really, really beneficial to have date time objects. Instead, this time we'll reload the file. This time we're going to use the index column equals timestamp to indicate we want that column to be the index. And we're going to use an attribute for this function called parse dates equals true. This is going to be really important for us because it converts up here. We saw this date timestamp here in the file itself. It's just a string. It doesn't mean anything. But when we use parse dates, it's going to go through and understand that 2016 is the year, 01 means January, 01 means January 1st, and 00000 means midnight, essentially. So let's see how that works. So we've loaded that. Let's look at the dot head as well. You can see that the timestamp now is in the index column. And if we look at what the dot index and the first value of dot index, it is, instead of 0, it is a timestamp. It has a timestamp object, which we'll show here in a second why that's so cool. So timestamp object attributes we learned a little bit about. Let's take a closer look in the context of this data set. Here you can see this whole data set now. If you do dot index, you're going to see a date time index and a series of objects, which are the object data type is date time, which is what Pandas essentially uses. What can we do with this date time index? Well, if we take that first index, once again, we use a function on top of that date time index called dot month. What will happen is it will pull out what month of the year that timestamp is. So if you wanted to filter according to all points in January, you could do that very easily once you have your data in this date time format. You wanted to look at days of the week. With Pandas and Python, each day of the week has a number. The week begins on Sunday, with Sunday being 0. 4 is the day of the week. So if we wanted all the Thursdays, if we wanted to know week of the year, we could do that. We could pull that out. We want to know, is it a leap year? Yes. So that particular year is a leap year. 2016 is the beginning of that data set. So that's a leap year. That's true. Which hour it is, it's midnight or 0 hour. So filtering and using this date timestamp is very possible in that sense.